In this video, we will be discussing section 13.4, which begins on page 875 of your textbook, and is entitled Evaluate Inverse Trigonometric Functions. So, suppose you were to find an angle theta whose sine is 1/2. After considering the problem, you realize there are many such angles. For existence, pi over 6, which is 30 degrees, 5 pi over 6, which is 150 degrees, and so on. All of them have the sine value of 1/2. To create a unique, we are looking for a unique angle theta, such that the sine of theta equals 1/2, you must restrict the domain. Alright, and domain restrictions allow inverse sine, inverse cosine, inverse tangent to be defined. Alright, so we're trying to cut back, instead of having to, use the entire, quadrant 1, quadrant 2, quadrant 3, and 4, and keep going around and around and around in circles to produce the same sine value or cosine value or tangent value. We are cutting off a part of our coordinate plane here so that we can just, get one answer instead of infinitely many. So, looking at our key concept box here, they put some restrictions on my input and my output. So I'm going to kind of read these in a weird order. So first and foremost, we used these functions, inverse sine, inverse cosine, and inverse tangent, in geometry when we were looking for the angle. So we already knew the trig ratio. We knew, just like in the last example, 1/2. We knew that the output of a sine was 1/2, we just didn't know the angle measurement. So that's what we're using these inverse trig functions for. We're finding the angle measurement that produces those values. And so they put these restrictions on the domain. They put these restrictions on the domain, alright, which means that they're going to fall into a certain part of our graph here. And what that means is my output is going to be between certain values for sine and cosine. They're going to be between -1 and 1 for the inverse sine and cosine. And then for tangent, a is any real number. Alright, so we just kind of need to keep these restrictions in the back of our mind of where to start. Because sometimes when we use sine, cosine, and tangent, these values aren't possible. So we're going to put an answer that looks like undefined. If it's not in the domain, if it doesn't fall between these values, -pi over 2 and pi over 2, which is the same as -90 degrees and 90, or if it's between 0 and pi, it's between 0 and 180, and -pi over 2 and pi over 2, that is -90 and 90. And there's just one more small thing breaking down the technicalities here. Alright, for sine and cosine, they have the sine, and then for tangent, it has just less than, not less than or equal to. And the reason why is that tangent can't actually equal any multiples of pi over 2. That's just a really small restriction there that we will talk about more in depth in the next chapter. So let's go ahead and get some examples rolling here. Evaluate the expression in both radians and degrees. Alright, so that value right there should look familiar, especially if you've memorized your sine, cosine, and tangent table for 30, 45, and 60 degrees. So keep in mind, you should be able to construct this fairly easily. There's only 3 values and you need to memorize. So that is 1/2, which makes cosine of 60 1/2. 45 is radical 2 over 2 and radical 2 over 2, which leaves cosine radical 3 over 2. And then the sine of 60 would be radical 3 over 2. Right, those are only 3 values you have to memorize, and then you should be able to construct tangent from there. So we are looking for cosine of theta equals radical 3 over 2. And right away, I'm able to identify off my table that that is the cosine of 30 degrees. Alright, so then I would take 30 degrees and I would convert it to radians by multiplying by pi over 180, and I should get pi over 6. Alright, so looking at their solution and how they write it, when the cosine is between 0 and pi, so they have a little bit of a different restriction for us when it's between 0 and pi, which means between 0 and 180 degrees, the angle whose cosine is radical 3 over 2 is pi over 6, as well as 30 degrees in radians and degrees. So looking at another example, evaluate the expression in both radians and degrees. So one thing that we can do on all of these is we can, double check. Right now it says 2, alright, so there's no pi in there, so I need to make sure that I am in degrees, which I am, alright, by looking at your mode. So I press the inverse sign of 2, and then I press enter, and I get a domain error. So you can always double check and get an initial tip off from your calculator. This is undefined. Alright, so if I go back to my table here, my table says my inverse sign must be, that a value must be between -1 and 1. And in this case, it was not. So domain error, so it is undefined. Undefined is what you would type in or write. So evaluate the expression in both radians and degrees. So if I have my table memorized yet again, I would have something like this. I should be able to just use sine and cosine to find my tangent. Now there's one little thing that's throwing me off, and that's that negative sign. Alright, so I know that in order to get a tangent of radical 3, it needs to be of some form of 60 degrees. So I need to refer back to all students take calculus. When is my tangent negative? So my tangent is going to be negative in quadrant 2 and quadrant 4. And then I need to take into consideration those domain restrictions on tangent. So if I look back here, it says if I'm looking at tangent between negative pi over 2 and pi over 2. Oh, too far. Alright, I am going to be looking at when theta is between negative pi over 2 and pi over 2, which means that it's between negative 90 and 90 degrees. All angles whose tangent is negative radical 3 is going to be negative 60 degrees. Negative 60 degrees, right? Which means that it needs to be negative pi over 3. I always, they're writing it backwards than I would. I would normally find my degrees first and then find my radians from there, because I'm just so used to working in degrees. Alright, so on most calculators you can evaluate your inverse trig functions using the second sine key, second cosine, second tangent. On some other calculators you're going to have to press tangent, sine and cosine twice, and then some other calculators might be slightly different. So I want to go back to the last example here and just show you how to double check your work using it. So the tangent, inverse of negative radical 3, so I would press second tangent negative and shift radical 3, and then I would arrow over and close it out, and it gives me negative 60 degrees. It just spits it right out. Now I want you to keep in mind that you should have that table memorized in addition to being able to use your calculator. So looking at another example here, solve the equation sine theta equals -5/8, where we are sitting between 180 degrees and 270. So drawing out, I'm going to be between here and here, so I'm looking at this third quadrant. Alright, so I'm going to write out all students take calculus. Since it is a sine in the third quadrant, I know it is negative. Alright, so that checks out. So looking at what they do, use a calculator to determine that in the interval between -90 and 90 degrees, the angles whose sine is -5/8. So what I need to do is type this into my calculator, sine inverse of -5/8, and I would make sure to use your parentheses there. That is going to give me approximately 38.7 degrees. Alright, make sure that your mode is in degrees, degree mode. Alright, and this angle is in quadrant 4. Now, if you were paying attention a couple of seconds ago, that should be a little bit confusing because I said we were going to fall into quadrant 3. So, step 2, find the angle in quadrant 3 where theta is between 180 degrees and 270 degrees that has the same sine value as the angle in step 1. So what I would then do if I'm looking for that reference angle of 38.7 degrees, I simply am going to, instead of having 38.7 over here, I want 38.7 over here, so I am adding 38.7 degrees onto 180. Alright, use your calculator to check the answer. So if you type in the sine of 218.7 degrees, you should get approximately -0.625, which should be this very close to -5/8. Since we did round, it is going to be approximate, it won't be exact. Alright, so evaluate the expression in both radians and degrees. These are guided practice. So why don't you use your tables and your calculators, pause the video and see if you get the same solutions. Alright, we are now looking at example 3, some standardized test practice. So what is the measure of the angle theta in the triangle drawn? So I always find it helpful that when I have these angles that I'm talking about and I'm trying to use these inverse trig functions or my regular trig functions, I like to have the picture and label all my sides. So this is the side opposite, this is the hypotenuse, or that's not the hypotenuse, that's the side adjacent, and this is the hypotenuse. Alright, so I have the adjacent and hypotenuse. I always like to write out SOHCAHTOA. Alright, so which trig function am I going to use with adjacent and hypotenuse? Alright, and that's going to be cosine. So setting this up, cosine of theta equals 6/11. So if I take the cosine inverse of each side, that means I'm undoing the cosine. I'm going to get theta equals cosine inverse of 6/11. Alright, and looking at how they approach it, they have cosine equals adjacent over hypotenuse, exactly. So cosine inverse of 6/11, you type that into your calculator and you should get 56.9, just about. So your solution should be C. All right, monster trucks. So a monster truck drives off a ramp. A ramp is a very stereotypical triangle that we can use for trig, any type of ramp. The ramp has a height of 8, so here is my height of 8, and a horizontal length of 20 feet, so I want to find angle theta. Alright, draw a triangle that represents the ramp. There it is. Write a trig equation that involves the ratio. So if I were labeling this, I need the side opposite and I need the side adjacent. So we should be looking at tangent here. Tangent equals opposite over adjacent. And then use a calculator to find the measure of theta. So theta equals the tangent inverse of 8/20, which is approximately 21.8. You could also reduce it if you wanted to. The tangent inverse of 2/5 should give you the exact same value. So the angle of the ramp is about 22 degrees. So, guided practice. Find the measure of angle theta. You can pause your video and try these out and see if your solutions match up. Alright, if you guys have any questions with using these inverse trig functions, you should be able to do the second half of the section for sure, because we definitely did that in geometry. However, the first half with all those domain restrictions can get a little bit confusing. So I would recommend that you guys write at the top of your paper that all students take calculus and really look for those signs of whether they're negative or positive and try to figure out which quadrants they fall into and what the domain restriction on that is. Alright, so good luck and feel free to email me with questions.